Hello everyone, let's talk about the blood supply to the brain. Now the brain is incredibly metabolically active and it needs a constant blood supply because it needs oxygen, right? And so there's a very complex system of arterial supply to the brain, but only 4 pipes lead to the brain. We have 2 internal carotids on the anterior side of it, and we have 2 vertebral on the posterior aspect of it. They all come together to form this wonderful little thing called the circle of Willis. And you can see this here, how it sits in the brain. So this is the inferior surface of the brain here, the cerebrum. It's going to have the circle of Willis that forms around essentially where our hypothalamus is producing the infundibulum down to the pituitary, as well as our optic nerves and our mammillary bodies as well. You can see that it is highly complex. So we're going to start with the posterior aspect and then work our way forward from there. So when we look at the posterior aspect, we have our 2 vertebral arteries right here. Now the vertebral arteries come up through the vertebra, the transverse foramen specifically, and as it comes up, it's going to take 2 90-degree turns up into the foramen magnum, and then it's going to come together to form this big basilar artery. All right. Now, backing up, the vertebral arteries here have a couple of branches. The first one's the anterior spinal artery, and that anterior spinal artery is going to dive down onto the anterior surface of the spinal cord, and it'll pick up branches along the way, but it does the entire anterior surface of the spinal cord. We're going to talk about pica, ica, and superior cerebellar artery here on the next slide, but posterior inferior cerebellar artery we know is pica, anterior inferior cerebellar artery, AICA, or ICA to some people, and then superior cerebellar artery, we just abbreviate SCA. These vertebral arteries are going to come together to form this big basilar artery. Now, the basilar artery is going to oversit the entire brainstem, right? So the medulla, the pons, the midbrain, and you can see too that there's a lot of little tiny arteries that come off of it. This shows only 4. It can be a wide variety of branches, but these are all pontine arteries. Now, the pons is going to have 4 of our cranial nerves in it that are going to be important for a lot of different things. Same thing for the medulla. It's going to have 4 different cranial nerves, and the midbrain will have 2, as well as it'll have 2 above it in the brain. So you can see we have a ton of blood supply here. As the basilar artery comes up, it will then split into the posterior cerebral arteries, and those are going to go to the occipital lobe back here, as well as project forward into the thalamus a little bit. Let's look specifically, though, at the ones that are coming off that we talked about a little bit, the pica, ica, and superior cerebellar artery. So when we talk about the pica, posterior inferior cerebellar artery, all right, this is going to do the choroid plexus, so how we get CSF into the brain. The medulla, so we're going to have quite a lot of different centers here, specifically like our heart rate, our gag reflex, swallowing, voice, all of those are in the medulla. And then also the cerebellar tonsils. And so those cerebellar tonsils are going to help with balance and smooth motor control. But really the pica is going to do the inferior surface of the cerebellum, as well as the inferior vermis. So if we look at the cerebellum, you got you have several lobes, but you have the 2 main lobes, and right in the middle is a worm-like structure called the vermis, which is why it's called that. So the vermis is going to do posture and locomotion. Above it is going to be, from that basilar artery, is the AICA, or ICA, depending on who you talk to, right? So anterior inferior cerebellar artery. This one is going to do anterior and some inferior surface of the cerebellum. It's also going to assist with the pons because it crosses it, and anytime an artery crosses something, a lot of times it'll drop off a few branches to it to just help assist with the other ones that are there. As well as the ICA is going to produce an inner ear artery too. So that's going to go through the internal acoustic meatus into the inner ear structures for the labyrinth and the cochlea. And then finally we have the superior cerebellar artery, and this is going to do the superior cerebellum and anastomoses here with the AICA, right? And so you can see it goes right over top of the pons a little bit, right over top of the midbrain, and so it will help with those structures. It's also going to help with the superior and middle cerebellar peduncles. as well as it can be implicated if there's a problem with the superior cerebellar artery, could be implicated in trigeminal neuralgia. So when we look back at these structures, you can see how incredibly important they are. They are right over top of all the structures that control your automatic necessary vital needs, right? So our heart rate, breathing, it's also going to control things to our face, hearing, all of those structures. So it can be really devastating if you get a stroke back here, especially in the basilar artery. So usually if you get a stroke here in the basilar artery, if you survive it, you may end up with something called locked-in syndrome. So locked-in syndrome, you are perfectly aware of everything that's going on, except the only thing you can really move is your eyes. Some people, they're able to move their shoulders, but that's pretty rare. Now, what we see here is that posterior cerebral artery, that one going to the occipital lobe there, it's got a little branch that's running anteriorly. Now, this little anastomosis here is called the posterior communicating artery, and that posterior communicating artery is anastomosing with the middle cerebral artery. So let's back up. We see our circle of Willis is starting to take form here. We have our two big arteries that are entering the skull through the carotid foramen here, the carotid canal, and it's going to be the internal carotid artery. Now, the internal carotid artery is going to drop off this artery first, the ophthalmic artery. With a name like ophthalmic, we think that it's going to the eyes, right? So it's going to head that direction. It will also drop off, the ophthalmic will drop off another artery called the central artery of the retina, and that's going to go through the optic nerve to the retina. After it does this, the internal carotid, and depending on what sources you look at, and there's always some differences between people, the internal carotid is either going to bifurcate into the anterior cerebral artery or the middle cerebral artery. And that middle cerebral artery is huge. It's going to go to the lateral aspects of our brain. All right. If you're going to get a stroke, most of the time, especially if it's an ischemic stroke from a clot, it'll end up in these middle cerebral arteries here. So if we look back at the homunculus, right, we can see that the face and the arm are heavily, heavily impacted. So when we talk about stroke, remember be fast or faster or just fast, face, arm, speech, and time, right? So this is why a lot of times you'll see face and arm implicated in stroke. And we use those symptoms as a marker of stroke because most of the time the middle cerebral artery is impacted. Now, this anterior cerebral artery is running forward, and that's going to go medially. So it's going to do the middle aspects of the brain right here. And we, again, see that that's mostly leg. All right. So you can get some different presentations with stroke. All right. Now, if we look back, we have to complete our circle of Willis. So we need to connect the circle, and that's the anterior communicating artery here. Now, whether or not these fully anastomose, whether or not we fully have a circle of Willis, this is up to anatomical variation. There's also some discussion of whether or not these help with the perfusion if there is an occlusion somewhere. Some people say that it's really just to help with pressure. You'll see several different sources, but that's the arterial supply to the brain. Let me know if you have any questions in the comments.